will be proctored. The quizzes will be proctored. The exams will be proctored. Everybody must be visible throughout the quiz. At the end of the quiz, you will say, you will do this. So some say you finished your quiz and you say, now then you'll tell me that I'm going to submit the quiz, or maybe at the end. I will give you, so it is 2 to 2:40, and I will give you 10 minutes to get ready. So you will scan and do whatever. You must submit your entire exam as one, as a single, I repeat the word single, PDF file, not pictures, not blah, 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 not 10 pictures or 4 pictures, not like that, as a single PDF file. Okay, so it will be like this: amitkaran.pdf, Ariel Moskowitz.pdf, Victor Cortes.pdf, or even if Victoria Cortes, VictoriaCortes.pdf or Victoria.pdf, Amit.pdf, ArleyEvents.pdf, whatever. But it should be like this. Like, okay, and there will be 4 questions: one on Kramer's rule, one on finding inverse of a matrix using adjoint. I'll show you another method today, but that's not on the exam, or not on the quiz. Finding the inverse of a matrix using adjoint. Number 3 will be how to evaluate a determinant. I will give you a 4x4 determinant, row reduction. What was the question? Repeat that, please. Somebody asked a question by chat, and that's what I don't like. Do we send the PDF to the email? You email us? No. Yeah, I mean, just reply button. That's okay. You know, the exam will start at 2 p.m., right? So just 5 minutes before the exam, I mean the quiz, I will send you the quiz by PDF file, by email as a PDF file. Okay. So just reply to that. That's all. Yeah, and you should submit it by email, obviously. No question about that. So don't distract me. So then 4x4 determinant, evaluating, I will give you a 4x4 determinant, you know, by row reduction, the way you did it last time. Okay.
So, Professor, that makes it 3 questions on the quiz. You just said 4.
Exactly. Just give me a little time.
Is the last one going to be a fun question?
Okay. Now finally, let's now. Okay, let's finish this. Finally, the one problem will be something about some, not fun question. I mean something about matrices. Matrices or determinants. We did lots of problems. Very elementary. Matrices or determinants. You saw those problems on determinants that we did last time. So today, first thing I'm going to do is that I will give you a simple review. Ooh.
Probably a practice quiz would help.
Oh, a quiz is a practice exam. A practice quiz. Then you will ask for a practice quiz. Huh? How about that? Practice quiz. You don't need a practice quiz. Just a review will be enough for you. Got it?
Yeah, that's true. I mean, I get so nervous in the exams.
Who said she gets very nervous on the exam?
Shania.
You get nervous on the exam? After so many, after I'm going through so many problems. Hello? Nothing to get nervous on the exam. Nothing to get nervous on the exam. So let's take something like, let's take a problem like this. Here is a good. So here is a review. Just one question each. You will understand what I have in mind. Number one, use adjoint to find A inverse if A is, let's take this, wait, 3, 2, minus 1, 1, 6, 10, 2, 9, 5. Use adjoint to find A inverse. So step one, so what do you do? You remember A inverse is 1 upon determinant of A times adjoint of A. Yes or no?
Yes.
Yes, very good. You remember that. Good. So we have to find the determinant of A, for which it is easy to do the, just expand along the first row. Determinant of A is 3 plus minus plus 3 times 5, 6, 30. 30 minus 90 minus 60 minus 2 times 5 minus 10. 5 minus 20 minus 1 times plus minus 1. 9 minus 12. So minus 180 plus 30 plus 3. Okay, let's do this. So let's see, what do you get? Minus 180 plus 30 minus 150. Nah? Then that is minus 147. Is this right? All of you? Good. So that's the determinant. Now I want to do the matrix of cofactors. I want to find the matrix of cofactors. So remember, plus, minus, plus, minus, plus, minus, plus, minus, plus. So matrix of cofactors. Matrix of cofactors. Remember, plus, minus, plus. You got the signs here. So 3 times, so 30, do it with me and check whether I'm doing it right. 30 minus 90, 30 minus 90 minus 60. 5 minus 20 is minus 15 with a negative sign. 9 minus 12. 10 minus minus 9, 19 with a negative sign. Plus. 15 minus minus 2, 17 with a positive sign. 27 minus 4, 23 with a negative sign. 20 minus minus 6, 26. 30 minus minus 1, 31. 18 minus 2, 16. That's the matrix of cofactors. So what is the adjoint? It's the transpose of the matrix of cofactors.
I'm sorry, Professor. Can you repeat the cofactors again? I'm a little bit lost.
Where are you lost?
Just how did we find again minus 60? You know, I was trying to do it by myself.
Okay, stop the conversation, please. Mute yourself. I'll mute yourself. Mute yourself. How did you get these numbers? What do you mean? The cofactors. Oh my goodness, at this stage you are asking this. These are the signs, plus, minus, plus, etc. So for the cofactor C11, what is C11? Yeah, take the minor, but with the signs. So for 311, what do you do? As if you take this out, 5, 6 are 30, 30 minus 90, minus 60. Okay? Like that, exactly like that. So what is your specific question? Do you have a specific question on any particular number? No, then
No, I'm good. Thank you.
okay, adjoint of A is the transpose of this matrix. So minus 60, 15, minus 3, minus 19, 17, minus 23, 26, minus 31, 16. A inverse is 1 upon determinant of A times this. And I just made up the numbers. That's why you get such funny. You don't get neat inverse, obviously, but that is just because I made up the numbers.
Professor?
Wait, just a minute. Question?
Yeah.
Question, yes?
On the quiz, do you want us to reduce it or just keep it like this?
No, reduce to what? Here it is. You mean to say that whether you want to cancel it, simplify it? That's what you're saying?
Yeah, simplify it.
No, just leave it like this. So I was a little puzzled by that question. How do you get those numbers? That was, at this point, it is very scary. You have a matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. You have a matrix like this. What you do is you find the minors. So minor of A11 is, this is how you do it. A11 appears in this row, first column, as if you delete this, as if you delete that. Then you have this determinant A22, A23, A32, A33. That's the minor. And then what is the cofactor? Cofactor of A11 is actually minus 1 to the power I plus j, 1 plus 1 of the minor. That's the idea. So what will be the minor? So for example, suppose you take this A11, A12.
Professor,
Yes.
Can you scroll up a little bit? Is you write down 3 over 147 is not as 30.
Just a minute. Which one?
On the A inverse,
Yeah.
at the last row, is it
Yeah,
3
yeah.
over 1, 3 over negative 3 or 3 over?
No, -3 over -147.
Okay.
You made a mistake because on the last row, that
Mhm.
31 over 147, that's supposed to be a 23 over 147.
Oh, good. Absolutely. Absolutely. Thank
That's
you.
what I was saying.
Yeah. I did. My eyes went to this one. Yes, good. Good. Everything else is no. No. Wait. 60 upon this is right. This is right. This is right. This is good. Yeah, my eyes suddenly went to the matrix of cofactors. You have to do it with adjoint, careful. So as I was explaining this, so what is the minor of say this guy? Minor of A23. Well, it appears on the
It's
second row.
A11,
Third column. Yeah. Cross this.
A31, A32.
You have A11, A12, A31, A32. That's the minor. M of 2, 3. What's the cofactor? Cofactor will be -1 to the power 2 plus 3, M of 2, 3. So always remember, cofactor of Aij is -1 to the power I plus j, minor of Aij, where Mij is the minor. Why don't you practice two problems like this? I think that would be good. Why don't you do this? Let's see. Practice. Practice 1. Find A inverse if A is 3, 2, -1, 1, 6, 3, 2, -4, 0. Do it, let's see. I give you some time. Give you 10 minutes, not more than 10 minutes. This Thursday is your quiz, so Yeah, try to do very well on the quiz. And I'm going to give you some good practice problems. What's the answer? What is the determinant of A? Determinant of the matrix A. Use the cofactor expression, cofactor expansion along the first row. So that is 0 minus minus 12. So that is 12 minus 2, 0 minus 6, minus 1, minus 4, minus 12, minus 16. Okay, now I always prefer to write it this put the sign so that we don't make mistakes. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So matrix.
We let's see what you're doing.
Sorry.
The screen is not showing what you're doing. It's not on the screen.
Huh?
We can't see on the screen is not showing anything. Are you writing on the screen?
I'm writing on the screen. Hello.
We
No,
can't
not
see
even
that.
showing up.
What do you
It's
mean?
not working.
Is that okay? Is it okay?
No.
No,
No?
no.
What do you mean? Wait. How come? I can see.
Your screen is there, but we don't see you writing anything.
We only see the problem, but you know, as you're doing it, I'm sorry, as you're doing it, we cannot see.
Yeah, there is a connection issue. Wait a second. Let me connect this. Why? This is now a black screen. How can this happen? Okay, wait a second. Something is funny now. Everything was fine. What's gone wrong? Oh. Okay, then let's see. Share. Hello?
We see it. Try writing something.
Yeah. Matrix of cofactors.
Okay, it's working now.
Thank you so much. When are we going to go back to the campus? I can't live like this.
Either, Professor. Said me either. I'd rather be
Exactly.
We can't either.
Really, this is so. I mean, I will get sick because of this, not because of COVID-19, because of this. Okay, now fine. Every time something weird happens. Okay, now matrix of cofactors. Let's see. Immediately tell me if something goes wrong. Okay. So let's see. 0 minus minus 12. Yeah, 12. You can read, right? Hello? Okay. Plus minus. So 0 minus minus 6. 0 minus 6. 0 minus 6. With a negative sign. Minus 4 minus 12 minus 16. 0 minus 4 minus 4 minus 0 minus minus 2, that is 2. Did I get this right? Let us check. 0 minus minus 4. So that is minus 4 with the negative sign. Yeah, that's right. Minus 12 minus 4 minus 16 with the negative sign. Six minus minus 6, 12. You see, do all of you understand? All of you are getting it, right? Say, for example, I'm finding the minor of minus 4, this guy. So what I do is I get this out as if it's not here, and I take this determinant, that is, which is a 9, 9 minus minus 1, 10, with a negative sign. Similarly here, 18 minus 2, 16. And then adjoint of A will be the transpose of the matrix of cofactors. So what is the A inverse? It is 1 upon determinant of A, adjoint of A. Determinant of A is 64, no? So 12 upon 64, 6 upon 64, minus 16 upon 64, 4 upon 64, 2 upon 64, 16 upon 64, 12 upon 64, minus 10 upon 64, 16 upon 64. Somebody asked me this question, do I need to simplify? No, you don't need to simplify. Wait, what was the question? What was the question? No, you don't need to simplify. What was the question? Somebody asked me a question. You didn't take the adjoint. What do you mean I didn't take the adjoint? Oh, wait. Oh, yeah, I didn't take the adjoint. Wait. My friend was correct. No, let me see. Adjoint is the transpose. Yeah, I simply I simply copied the matrix. That's wrong. Adjoint is the transpose of this. Transpose. Let me write it in words. Of, you don't have to do it, of the matrix of cofactors, so that there will be no ambiguities when you do it. So now take the transpose. 12, 6 minus 16. 4, 2, 16. 12 minus 10, 16. Yeah, now A inverse is 1 upon determinant of A, adjoint of A. So now it's okay, 64 is the determinant, so 12 upon 64. The answer to that question, whether we have to simplify these numbers, no, you just keep them as they are like this.
Do you give partial credit for like if you happen to make like a small error?
Yeah, of course. No
Okay.
question.
Thank you.
Okay. Do you want one more practice? Just one more.
Sure.
Yes? We will do, I'll do Kramer's rule. I will do everything. Wait. So just, can you scroll up? Okay? Now, okay, just practice one more. Practice one more problem. Practice two. Use adjoint to find inverse. I mean, there was something else but I don't want to confuse you. I will do that later. Find inverse if A 3, 2, 1, 9, 6 minus 5, 1, 2, 5, maybe 1 to 4. Do it, let's say.
So, Professor, for the
Professor.
previous solution, I got a -6 on the first one. I don't know.
Which one?
Can you go a little up? You got +6, but I got -6.
Where?
Right here, it's 12, 6, 60 minus 16. I got -6 because
Wait. Are you talking about this one?
yes, because 110
Wait. Okay, somebody is talking there. Mute that. Okay, this will be, wait. So this goes away. 0 minus 6. So that is -6 with a negative sign. So that is +6. Got it? Did that answer your question?
Yeah, I think I made a mistake.
Okay, do this now.
Professor,
Yeah.
can you go back to the same matrix? Yes, here. The cofactor matrix. On the first row, last column, -16.
Yeah,
At the bottom also, I think it's -16. Can you check it?
Are you talking about this one?
The second row, last column. Instead of 16, this one, I got -16. Can you check it again?
me
Yeah,
too.
yeah,
I got -16.
Maybe they were right because you see, when I'm doing it on the iPad, my matrix is hidden. my matrix is hidden. I cannot see my matrix. So this is a -2. Remember, there was a -2 here. My -4 here. -12, -4, -16 with a negative sign. So it's 16. It's 16. You see, this goes away. You are left with -12, -16, -4, that is -16 with a negative sign.
Yes, thank you. Yes.
Yeah, now do this problem. So for the quiz, there will be no makeups, remember, except for medical emergency, because otherwise things get very complicated. And you must come on time. The quiz will start on dot 2 p.m. Okay, so what's the determinant at least? 38 is the determinant. Okay, let's see. 24 minus, oh my goodness, another person says 196. Let's 24 minus 10. 24 plus 10, 34. 24 minus 10. 36, 4 9 is 36. 36 minus 5. Look, stop the noise, please. 36 minus 5. Eighteen minus 6, 12. 12.
Professor, 36 minus 5.
36 minus 5 is 41.
Oh, yes.
32 is the correct answer. 32 is the correct answer. So now the matrix of cofactors. Matrix of cofactors. Let's see. 24 minus 10.
And if I press cancel, I can't hear him. So
36 minus 5, 41 with a negative sign. 18 minus 6. 8 minus 2, 6 with a negative sign. 12 minus 1, 11. 6 minus 2, 4 with a negative sign. Minus 10 minus 6, minus 16. Why? This is about what confuses you. Minus 15 minus 9, minus 24 with a negative sign. 18 minus 18, 0. Okay, so what is the adjoint? Let's not make a mistake. We are going to take the transpose of this guy.
no, he would have
34 minus 41, 12, minus 6, 11, minus 4, minus 16. Can you stop that talking, please, over there? Hello? You're disturbing me. 24, 0. And what is A inverse? 1 upon determinant of A adjoint of A. (34 upon 32). Yeah, what was the question? What was the question again? What are those funny questions I'm getting? What's the question? You have to practice this. This is very easy. You get the determinant. What numbers are you getting? You're talking about these numbers as I repeatedly explain this. You take the minors with, and then you use the signs, the corresponding signs. The signs are here. Here's the sign. Yeah.
Professor.
Yeah.
For the determinant, isn't it -1 times -12, right? Or
no, the determinant is correct. It's right.
-1 times 12, isn't it?
No, plus minus plus.
No, plus minus plus.
Can you can
Can
can you do this? Eighteen minus 6, 12 with the positive sign. Yeah. So that's positive. Yeah, everything seems so okay here. Any questions? See, actually, if you have a question, you just ask me, but immediately mute your speaker, because I think when I speak, it gets, some of the speakers are not very perfect, so it gets echoed. Any questions, anybody? Any questions, anybody? Huh? No? Okay. Art Evans was asking me a question. I said that there will be 4 questions, 4 problems. I'm going to review. I'm going to definitely review. Thank you. No problem, Caesar. I'm going to review Kramer's rule. I'm going to review. No, there were 4 questions I said. Yeah, you came late, so you missed.
Is there it's gonna for 30 minutes we can do 4 questions?
No, I'm not giving you 30 minutes. I'm giving you 2 p.m. to 2:40 p.m.
So 40 minutes.
Yes, please.
Okay.
That was the last class. You come to class on time. Okay. So here's a problem for you. Let's see. Arlie Evans was asking me what will be the 4th question? What kind of? Well, this is not going to be the 4th question, but this is something like this, very important. Let's see who can do this. Prove that the inverse. Oops. No, I don't like. I don't like proofs. Somebody is writing to me. I don't like proofs. My friend, I love proofs. So let's have fun. I really like proofs. Not me. Okay. How will you prove this? Prove that the inverse of the adjoint of A, and this gives us a very interesting result. Note the extreme left part, inverse of the adjoint of A, and note the extreme right part, adjoint of A inverse. Isn't that a very nice result? That the inverse of the adjoint of A is the same as adjoint of A inverse. And here's the formula for this. 1 upon determinant of A times A. How will you prove it? I give you 5 minutes. Let's see. Okay, let me show you. See, one thing you remember, determinant of A inverse is determinant of I. A inverse is I, identity matrix. Determinant of AB is determinant of A times determinant of B. So determinant of A times determinant of A inverse is equal to 1. So determinant of A inverse is 1 upon determinant of A. Right? Now, so there are 2 things here. You have to prove this part, you have to prove this part. So listen, let me explain. You have to prove this part, look at my pen. You have to prove this part, and then you have to prove this part. Okay, so let us try to do this part. Okay, so let X be A inverse. We have been using this result again and again. A inverse is this. So we know that X inverse is 1 upon determinant of X times adjoint of X. Now, determinant of X is determinant of A inverse, which is 1 upon determinant of A. So, this implies X inverse, A inverse inverse. Now, wait a second, what did I do? Adjoint of X. This is not going to help me. No, this is not going to help me. Don't do that. That is the trick. There is a trick here. There is a trick here, my friends. Wait. Okay. Use this formula here. So adjoint of A is A inverse times determinant of A. So adjoint of X is equal to the determinant of X times X inverse. This will do it. This implies adjoint of X is A inverse, is determinant of X is determinant of 1 upon determinant of A inverse inverse. That implies adjoint of A inverse is equal to 1 upon determinant of A. That proves this part. Now I'm going to prove the other part. Now, in order to prove the other part, I'm going to do this. Next. So adjoint of A inverse, I want to show that, no? So adjoint of A times 1 upon determinant A times A. What should you get? That's equal to adjoint of A. So 1 upon determinant of A times adjoint of A times A. And that is A inverse times A, and that is R. Also, 1 upon determinant of A times A times adjoint of A is equal to 1 upon determinant of A No, is equal to A times 1 upon determinant of A. That's a scalar. So I can play with that easily. But this guy is A inverse. That is I. Hence, what do we conclude? Hence, we conclude that adjoint of A times 1 upon determinant of A times A is 1 upon determinant of A times A of adjoint of A. And that implies the inverse of adjoint of A is precisely this proves this part. You must be remembering that I gave this as a homework problem one day. And then we forgot to come back to this problem. Now, believe me, my friends, you are all set for the quiz. Let me do one problem, two problems, say, from Cramer's rule. If you understand this, then you're all set. Can you scroll up? Yes. This is a very good problem. This helps you to understand many things. Then you should be all set. Are you letting us go? No, I'm not letting you go. I'm going to do some Cramer's rule review. I'm going to let you do some Cramer's rule review. For example, use Cramer's rule to solve so if there is a blank, that means what? That means the coefficient is 0, right? So, what is the coefficient matrix? But if the determinant of the coefficient matrix turns out to be 0, then of course you cannot solve it. Then it is not solvable. Zero minus 25, 20. Minus 2 minus 2 minus 5. 10. So it is solvable. So what do you do now? You take A1 first, and you have this is the column matrix. So it becomes 10, 9, 5. Keep the rest as they are. 2, 3, 0, 5, minus 5, 1. A2, 10, 9, 5. 1 minus 2, 1. 3, 5, 1. A3, 10, 9, 5. 10, 1 minus 2, 1. 1 minus 2, 1. 2, 0, 0 minus 5. Okay, now determinant of A1. Zero minus 25. Hi, minus 25. No, 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 no. 0 minus 25. So that is 25. Minus 2 times 9 minus 25. 9 minus 25 minus 16. Minus 45. That gives you what? 250 plus 32 minus 135.
It's like 147.
Huh?
147. What color?
147. That's what you are saying. 282 minus 135. 147. 147. Determinant of A2. Nine minus 25 minus 60. Minus 2 minus 5 minus 7. Minus 10 minus 9. Minus 73. Zero minus 45. Minus 10 minus 9. 10. This is 73, 83, 183. So the variables for x1, x2, x3. No? So x1 will be determinant of A1 upon determinant of A. 147 over 69. X2 similarly determinant of A2 upon the minus 3 upon 69. You can leave it like this. X3 is 183 over 60. That's the Cramer's rule practice. Do one problem like this, just for practice. Practice 2. So use Cramer's rule. Yeah, do this. That's a 3, not a minus. Oh. Team. 6. 8 minus 6. 2 minus 3.
It's 11.
Hmm? 1, 2, 3. And finally, two, 5, 3. Minus 1, minus 1, 1, minus 1. Three minus minus 2, 5. 15 minus 6. Minus 5 minus 3 minus. Okay, so x1, the determinant of a1, 19 on 22. x2 is 11 upon 22. x3 is 11 upon 22. Okay, now do one determinant.
For determinant A1, I think it's 11 too, not 19.
Okay, let us see. Let us check. Let's check, my friends. 1, 2, 3.
2 instead of 6.
Wait. Okay, wait. Okay. Let's see. 1, 4 minus 2, that is 6. Minus 1, plus 1. 8 minus 6, 14. Plus 1. 2 minus 3, minus 1. Hello. 6 plus 14 minus 1.
The last row, Professor, is 3 negative 1, 4.
Yeah, 3 negative 1, 4 for the last line.
For the last row.
1, 2, 3, minus 1, 1, minus 2, minus 1. Okay. Oh my goodness. Wait. Oh, did I get everything? Other ones correct?
Yeah, the other is correct.
Okay, wait. Let's see. Just a minute. Wait. 1 determinant of A1. 4. Oh, then everything changes. 4 minus 2. This becomes 4 minus 2. Then this becomes 2 plus 1. 8. That is okay. Plus minus plus. Minus 2 minus 3 minus 2 minus 3 minus 5. So then then 2 plus 4 minus 5. This is 11. Is this what you got? Hello?
I got 11.
Yes, that's
Oh my goodness, all these things are 11. What a nice answer. That was a pure accident, by the way. That means, what a nice answer. Can you ever get this kind of an answer? x1 equal to x2 equal to x3 equal to half. That was just an accident. That was just an accident. Yeah. Okay, let's do one problem on determinant. Yeah, row reduction. That's what I'm going to do. Use row reduction to evaluate two, 3 minus 1, 6, 1, 5, 2, 9, minus 3, 4, 1, 6, 3, 0, minus 1, 2. Say this one. So what do you do? First, you interchange. If you interchange two rows, then you introduce a negative sign. Multiply the first row by minus 1, right? Minus 2. Add it to the second row. Minus 2, no? Minus 10 plus 3, minus 7. 4 minus 2. That is minus 4, minus 1. Minus 2, which is minus 4, minus 1, yeah. Minus 2. Minus 18 plus 6. Multiply the first row by 3, add it to the third row. 15 plus 4, 19. 3, 6 plus 1, 7. 27 plus 6, 33. Multiply the first row by minus 3, add it to the fourth row. Minus 15. By minus 3, no? Minus 3, minus 6, minus 1, minus 7. Minus 27 plus 2. Minus 27 plus 2, minus 25. Now I will expand along the first column. That's the trick. Then I get only this. Unfortunately, since I made up the numbers arbitrarily, the numbers don't come out properly. I mean, the numbers are really ugly. Yeah, numbers are really ugly. I mean, I'll get some fractions, blah, blah, blah. That makes my life miserable, but anyway. What should you do? You multiply. Suppose I multiply the first row by 1 upon 7. No, minus 1 upon 7. Then it's minus minus plus. 4 by 4, not 4 by 4 matrices, yeah, 4 by 4 determinants, there will be. So wait, you multiply this 1 by 7, right? So then you get what? You did flip the first row and second row, and that's why you got the negative sign right at the beginning. 1, 5 upon 7, 12 upon 7, 19, 7, 33. Minus 15, minus 7, minus 25. Oh, no, sorry, not matrix sign. Determinants, we are doing determinants. Okay, and then it is okay, because 1 upon 7, it's a little ugly, but so what? Multiply the first row by minus 19, add it to the second row. So you must have a calculator that day. Minus 19, nah? Minus 19. Remember that, multiplying the first row by minus 19. 19 times 5 is minus 95. Achha, 95 minus 95 upon 7. Minus 95 upon 7 plus 7. That gives me minus 95 plus 49 upon 7. So that is 40 minus minus 46 upon 7. Minus 46 upon 7. Again, multiply by minus 19. And okay, oh my goodness. Oh, that's because I made up the numbers, that's why. So 19 times 12 is 228. So minus 228 upon 7. Minus 228 upon 7. Minus 19. Minus 9. I'm multiplying this first row by minus 19. Minus 228 by 7 plus 33. So that will not be bad. So that is 7 3 is 21, 2, 7 3 is 21, 2, 31. Okay, that gives you a 3 upon 7. Multiply first row by 15, add it to the third row, 0. 15 5 is 75 upon 7. 75 upon 7 minus 7. 7 7 is 49. 75 minus 49. 75 minus 49 is what? 75 minus 49 is 26. 75 minus 49 is 26, exactly as I said. 26 upon 7. Multiply the first row by 15. 15 times 12. 15 times 12 is 180 upon 7. Add it to the third row. Multiply this by 15. Nah? 15 times 12. We are 180 upon 7. Add it to the third row. So 180 upon 7. 180 upon 7 minus 25. So that is 180 minus 7 5 is 35. 7 2s are 14. 17. Oh, 5 by 7. Expand along the first column. Along this column. So it is simply, so this, only this. So that you can easily work out. So that is 1 upon 7 times 46 times 5 minus 30 minus 230 upon 7. 26 times 3. It's a horrible answer, but that's because I made up the numbers. But let me give you another practice so that things are okay. Let me give you another practice. Why should I divide by interest? I multiplied, it's 1 upon 7. Why? Wait, what are you? I took 1 upon, I multiplied the first row by 1 upon 7. So that's 1 upon 7 came out. Do this. Use row reduction to evaluate. This is a good simple problem, and then this should be okay. -1, -2, -3, -4, 4, 3, 2, 1, 1, 2, 3, 4, -4, minus. Oh no, this will be, this is going to be too easy actually. But do it. At least this is a practice. Yeah, actually this is a good practice. No, do it. So I multiply the first row by 1, by -1. So then I introduce a negative sign, minus. 1, 2, 3, 4, 4, 3, 2, 1, 1, 2, 3, 4, -4, -3, -2, -1. I interchange two columns, two rows, then I introduce a negative sign, isn't it? Let us go back to, because this is a review. So let us go back to what I told you. If B is the matrix that results when a single row or a single column is multiplied by a scalar k, then determinant of B is k times determinant of A. If B is the matrix that results when two rows or two columns of A are interchanged, then determinant of B equal to minus determinant of A. If B is the matrix that results when a multiple of one row of A is added to another, or a multiple of one column is added to another, determinant of B is determinant of A. Remember that? This is what I wrote. Please review that. So if I interchange the first and second row, I introduce a sign, negative sign. So then this becomes when you have two identical rows, what will happen to the determinant? 0, exactly. Oh. You understand why, right? Because you see, you have this 1, 2, 3, 4. If I multiply the first row by -1, yeah, good, very good. If I multiply the first row by -1 and add it to if I multiply the second row by -1, why should I do that? That would be even more neat for you. Multiply the second row by -1, add to the first row, then you get 0, 0, 0, 0. 1, 2, 3, 4, 4, 3, 2, 1, -4, -3, -2, -1. And then if you take the cofactor expansion along the first row, easily 0. Do one more row reduction problem and then we are all set. Negative what? Negative. Because I interchanged two rows, then I introduced a negative sign. So negative, negative, positive. Let's take this one. Yeah, this is a good one. Say 3, -1, 4, -5, 6, -2, 5, 2, 5, 8, 1, 4, -9, 3, -12, 15. Okay, that's the last problem. Suppose I multiplied by the. I always prefer to do that, but there's a. I want to always make it one, this leading element. But okay, suppose I want to make it. Multiply the first row by -3, add it to the second row. 3 minus 2, 1. -3, na? -12 plus 5. 15 plus 2. No. And also, multiply the first row by 3 and add it to the fourth row. Determine the zeros. She's so quick, very good. Multiply this by first by 3 and add it to the fourth row. 0, 3, that is -3. 0, 3. Ah, yes, 3 for 12, 0. -0, yes. Now you expand along the fourth row, so the answer is 0. Okay, I want to give you one more problem where the determinant doesn't turn out to be 0. Just do this one. That should be enough. Very good. That's it. That's it for today. So I interchange the first and second row. Then I multiply the first row by -3 and add it to the second row. Multiply the first row by -2 and add it to the third row. Multiply the first row by -3, add it to the fourth row. Now expand along the first column. Multiply the first row by -1. multiply the first row by minus 8, by minus 1, add it to the third row, minus 1. Minus 1, add it to the by minus 1. Expand along the first column. I made some mistakes. This is very disgusting. Okay. Multiply by minus 1, by minus 3, add it to the second row. Minus 6 plus 5. 3 minus 2, minus 3 plus 6. Okay. By minus 2, minus 2, okay. 2 plus 1, yeah, minus 2. 5 minus 2, yes, that is right. By minus 3, 7 minus 6 is 1. Minus 3. 3 plus 5 is 8. Minus 3, no? Oh, yeah, that is right. That's right. So what's the problem? That's right. Multiply this by minus 8. What bring the minus 1? Why? No? No? Minus, no. That's okay. Okay, 0, 3. 0, 3, 0, 3, 3, that's okay. Multiply this by 8. No. Multiply this by 1. Just add minus 1 plus 1. Oh, here, there you go. Multiply the first row by 1, add it to the third row. So that is, oh, I see what I did. That's fine. Multiply this by minus 1. 1 plus 8, 9. Oh, yeah, okay, got it. Multiply this by, I'm multiplying the first row by minus 1, adding it to the third row. Good. Minus 1, minus 3. So minus 9 minus, still there is a problem. What's the problem here?
Professor, shouldn't the first row be 1, negative 1, negative 3?
You are 100% correct. 1, negative 1, negative 3. Absolutely 100% correct. Yes. And therefore that makes my life better, because then this becomes, I'm multiplying by minus 1, then this thing becomes 3. Then I'm absolutely correct. 9 minus 27, the correct answer is minus 18. Good, that was a good review for your quiz. Okay, so remember quiz 1, Thursday, so class starts at 1:40, but definitely I will give you the exam at 1:45. So 2 p.m. to 2:45 p.m. Okay. So everybody must be ready with the camera and everything set. I'm going to send you the notes today, of course. Thank you. See you this Thursday. Everybody must come.
Okay, thank you, Professor. Bye-bye.
Thank you. Bye.